So in order to begin mainstreaming or integrating climate change considerations into day-to-day decision makings, we really need managers and decision makers to begin viewing their projects and plans through what you could consider a climate lens. And what that would entail is asking a series of questions as part of the regular planning process. So questions such as what impacts might be relevant to your project in terms of climate? Given those impacts, what actions could you take or what options do you have available? And then given those options, what will you do about it? How will you adjust your project to minimize your risks to climate change impacts? So this seems like a great approach in theory, but as with most things, it's much more difficult in practice. And one factor that adds to that difficulty is this proverbial gap that we're all very aware of between what would be considered useful climate information that's developed through things like climate models, and then what could be considered usable climate information that's more relevant to managers and decision makers, such as guidelines to manage risk. And what we really tried to do in developing this tool was to contribute towards narrowing or bridging that gap between these two kind of information forms. Now, this idea is not new. There are a variety of guidebooks out there, like you've heard about today, scenario visualization tools, databases, methodologies that all contribute to this goal of bridging the gap, of making climate information more accessible and usable to decision makers and managers. Yet many would still argue that this gap persists, and some folks have been looking at what sorts of strategies we can pursue to contribute to narrowing, to continue to narrow this gap. And so these authors of this recent 2012 article propose some strategies for narrowing the gap that include interaction efforts, what they call retailing, value adding, and customization to ease this transition from useful information to usable information. And the authors in this study also note that knowledge producers, many of you out there, or brokers, must understand user information needs and how to appropriately package, contextualize, and communicate subsets of existing information in an easy, user-friendly manner. And so these strategies and principles really underlie what we tried to do in creating this tool. So in creating the tool, we had 4 primary objectives. First, we wanted to make sure the tool was quick and simple to use. As has been mentioned here, these managers and decision makers don't have a lot of extra time on their hands. They have enough going on, especially with budget limitations that we all know about recently. And so we want to make sure this was quick and simple to use, that it didn't take a lot of time. Secondly, it was important to us that the tool consolidated information or packaged information, streamlined that information, and that it contained all the information that might be relevant to that decision maker in terms of climate impacts. Thirdly, it was important to us that the tool was customized or tailored to that specific user. So what I'm talking about here is providing these subsets of information that's only relevant to you and your project and your location. And then finally, it was important to us that the users of the tool really felt like they could own the tool and trust the tool, that was theirs to own and use. And we did that through some interaction efforts that I'll talk about. So first, making it simple. The tool takes what many outside of this room would consider to be pretty complex climate information and tries to distill it down into really simple bullet point sentences that people can easily take and use in their project planning and designs. This, of course, also includes interacting with the users of the tool, so for example, city government staff, to identify their level of risk aversion, which will inform which of the climate scenarios will be incorporated in these ranges, as well as what timeframes they're interested in looking at. Our second objective, making it quick. The tool only has about 5 steps that a user goes through. There are simple steps where one would just go through and identify some specifications about their project, the project time frame. They look at some maps to see the hazard zone within which their project is located. And that's it. And then they just receive some simple outputs, and they can review those and hopefully integrate and consider those in their planning. And it takes about 10 to 15 minutes for a user to complete. Our second objective was to make the tool consolidated and streamlined and comprehensive. So this graphic here is from the National Academy of Sciences report on adapting to the impacts of climate change. It overviews 6 primary steps in the adaptation planning process. And in building the tool, we sought out to consolidate these first 4 steps into one location. And also, we'd like to think that the tool kind of pushes partway into implementation and that it provides values that are easily ready and usable at the design phase of a project. We tried to make the tool comprehensive, and what I mean by that is taking multiple disparate sources of information and formats of information and kind of funneling it into one place in one simple output. So for the tool, we take climate information, as I mentioned. We also consider kind of best practices at the adaptation field, so that can be from those guidebooks or from other cities' climate action plans. We also consider regulations and policies. Those could be at the local level, the state level, the national level, to make sure that the recommendations we provide are consistent with the local regulation. And also, of course, the spatial information. So that could be in the form of GIS layers or even paper maps that the user could use to identify the hazard zones that their project might be exposed to. And so the tool takes all this information and kind of funnels it into one-page output per impact type. So there's one page for temperature, one page for precipitation and stream flow, and one page for sea level rise. And that's a screenshot, so that's what it looks like. Our third objective, to make the tool tailored and customized. This graphic here shows the different sectors that were included in the tool that we customized for a city in Vietnam. And so if a user was, say, an engineer interested in a civil works project, such as a new building, then they would simply input that. And you can see the output here is going to be specific to that sector and that project. So the impact overview and guidance information will be relevant to building construction. We build a customized version of the tool for each jurisdiction that we're working with. So we've worked with the city of Seattle so far, and as I mentioned, a city in Vietnam. And so these are screenshots of each of those customized versions of the tool. And we work with the stakeholders there to identify what sorts of formats of information, types of information they want included in the tool, how they'd like it presented, and those all inform how we go about the customization process. And then lastly, we wanted to make sure the tool was able to convey a sense of ownership by its users. And these pictures are from the process we went through to engage our stakeholders in Vietnam to inform the tool and the information contained therein. This picture on the right is Fong, our local collaborator, and he is talking with folks that were involved with the local vulnerability assessment there on what kinds of spatial information they wanted included in the tool. The picture below that is a fellow he's the manager of flood and storm control with the city, and he's talking with local city and provincial staff about not only the information that's going to be included in the tool, but also who's going to own the tool using forward, will it be required to be used, who will update it as new information arises, those sorts of questions. And this picture on the left is Dr. Nam. He's the director of the Urban Planning Institute in this city. And we were really excited. He actually really wanted to get up and present the tool to his colleagues in the city and provincial government. And we felt it was great that he felt empowered to be able to do that and kind of take ownership of the tool in front of his colleagues. Once we finish customizing the tool, we transfer it directly to the jurisdiction we're working with, and they own it, and they're responsible for updating it moving forward. We don't just hand it to them and say, see ya, hope you have fun. we conducted training. So this is a picture of us training the local administrators of the tool at the Planning Institute. And then we also designed a customized administrator guide that they can reference to help them update that information moving forward. So those are the design features of the tool that helped us meet these objectives that we had and kind of fill these gaps that we saw in the adaptation planning process and these decision support tools. How it works is, I kind of already mentioned it before, but it takes this embedded information that's kind of pre-wired into the tool during the customization process. And then that information is essentially filtered using user inputs, and that filter is applied to arrive at 3 primary outputs. First, a summary of the latest primary climate impacts. That would be changes in temperature that's projected for different time frames. Secondly, sector-specific impact information. So that would be specific to if you're building a new building, maybe you should think about these material features that might be especially impacted by climate change. And then lastly, some sector-specific guidelines and recommendations, or what I like to call the solution. The tool is housed in Excel, which is a platform that many folks feel comfortable using. They've used Excel before, so we like that feature. And it's composed of a series of tabs, like you see in Excel. So input tabs, output tabs, like I mentioned, temperature, sea level rise, precipitation, spatial tabs in this case that had those GIS layers that the users can consult to identify the hazard zones that their project's located within, and then some reference tabs that identify what sources of information were used to inform the tool's outputs. And then we also include some additional information on climate data if people are more interested in sort of those underlying assumptions or in scenarios that maybe weren't included in the tool's outputs. So I mentioned we developed this tool originally for the city of Seattle, and they're currently using it. This is what it looks like. This is the first page. You see it's just simple drop-down menus that the user can specify. Here's the second page, a little bit more information about a project. The user clicks this link, hyperlink on the right, and that leads them to the city's internal GIS system, which has maps that look like this, and the user would simply see whether they're in a flood-prone area or not, and then from there, they are given these output pages, which have on the left the primary climate impact summary, on the right the sector-specific impact summary, and then the far right guidance information. So does it work? We are currently working with the Office of Sustainability and Environment in Seattle to conduct a formal review to see how it's going, but we have heard anecdotal evidence that the tool was used by the Seattle Department of Transportation to redesign some joints for the University Bridge in Seattle to accommodate the projected higher temperatures out to 2050. So we're excited to hear that. The tool that we developed for Vietnam, they're using it now, and users are encouraged to submit this feedback form so we can get a little bit more information about how it's going and how we can improve the tool moving forward. So thanks to my funders and collaborators for this project, and thank you.